So I think it is, we left off on 9, right? Or we did 9. So we're going to skip 10 and 11. All right, we're just going to go to this finite, sum of a finite geometric sequence formula. So let's just go there. If I can get the presentation to run, it's not wanting to run right now. Go, come on. I hit a button and it doesn't like it. There we go. Oh, it's got that going now. Let's go back here. All right. So notice that word finite in there. If there's a finite one, that means there's also an infinite one. All right. So for geometric, we have two different types of sums. We can sum the ones that are finite, and we can also find the sums of the infinite ones. All right. In order to understand why we can get the sums of the infinite ones, you need calculus. All right, so we're not going to explain it. We're just going to know that it exists. Okay, so we will learn why in a few years. Okay. All right, so get that formula written. And there, if you do look out on the internet, there's a couple of different versions of the way people write this formula. I think this is the one your book uses. So, all right. So S probably stands for sum, doesn't it? Or the sum of the first n terms, right? Because we've got an n in there. What's a sub 1 always? The first term. All right, notice the R is in there twice. What's the R stand for? The common ratio, right? I'm just going to write ratio because I'm being lazy on a Friday. And then N is always what? The number of terms that we're trying to find the sum for. Okay. And again, you might want to highlight, underline, circle that word finite. And I did create something to help you memorize, or help you at least recognize the names of it to the formulas. We're going to look at it after we're done with the lesson, hopefully. Okay? Get you signed up for it. All right. So, let's take a look at doing one of these. All right. So this, typically we see, this is how they typically ask us to find the sum. You got to be careful a little bit. You got to watch where this starts, okay? And you got to watch what that is up here. If this is an n-1 and it starts at 1, that means my first term is typically whatever's hanging out in front here, okay? But we could put in, so technically there's a 1 hanging out in front there, okay? If you want to write the 1 in, you can. Let's just put that 1 in and calculate the first term. So I'm going to calculate my a sub 1 term by subbing 1 into the function there. So negative 2 to the 1 minus 1. What's 1 minus 1?
0.
What's anything to the 0 power?
1.
Do you see how I got the 1 that was in front? Okay. But you have to be careful. You really need to watch where this starts. Okay? All right. So now let's go ahead and apply our sum formula. So S sub n, what did they want? What's my sum? What am I going to? It's the biggest number. Do you see how the n is hidden up there? That's the final n value. Okay, so S sub 9 equals, we're supposed to put in our first term. What's our first term? 1. We calculated it and we know it's hiding in front there. So 1 times. All right. It's 1 minus r to the n. What's your ratio? Where's the ratio hiding? Okay, think about this. Didn't we have, let's look at the a sub n formula we talked about yesterday. What's the ratio? Negative. You see how it's hiding in there? See how this function is set up in that formula that we had? So whatever's in the parentheses is always our ratio. You need to be careful with the negative and put it in parentheses. But your new formula, it's not n minus 1, is it? It's just an n. So we go to the 9th power. So you got to be careful between yesterday's formula and today's. And then it's over 1 minus r, so 1 minus the negative 2. All right, what's going to happen with this double negative? Positive. All right, at this point, you guys, let's just put that whole thing into your calculator. See if you can do it. Be careful with where your parentheses are. You need to make sure that you do 1 minus, put a parentheses, -2, then close the parentheses to the 9th power. Okay? And then I'd hit a control divide to get the fraction. And you could probably do the 3 in your head, right? The 1 plus 2. So everybody plug it in and let's see what we get. We good with 171? Yeah. Everybody got it? Okay, remember, you want to make sure you're doing the calculator work, because on the test, I can't help you with that. All right? Especially when they get ugly and complicated like this. All right, let's check it out. Instead of an N, sometimes they use other letters here. They happen to use an I this time. Sometimes you'll see a K. Okay, so just gotta go with the flow on what the letter is. Okay? So let's think about this. If I put a 1 into here, what power does this become? 0. Anything to the 0 power is always what? 1. So doesn't that make this a sub 1? And what's the 1/4? That's your ratio, right? Okay, so see how it set it up for us. But again, you got to be careful. If this hadn't been a 1, that would have been a different a sub 1. All right? All right. What are we finding the sum for this time? How many terms? 6. It's coming from the top there is the n. So 6 equals, what's your first term? 32. All right. This one's going to be harder to get in the calculator. 1 minus, what's my ratio? 1/4 to the what power? 6 over 1 minus 1/4. All right. You're going to need control divide 3 times, right? You can get that all in the way it looks. Just make sure when you hit this one here, you do 1 minus, hit control divide, or parentheses, and hit a control divide to get the 1/4. Or could you put in 0.25? That's another way to deal with it. All right, I'm going to give you a minute. Don't call out the answer yet. Give everybody a chance to try to put it in. But try to type it exactly the way it looks right there. You will get a decimal point. Or you might get a decimal. If you can get the fractional answer, great. All right, what did we get for the fraction? Not even close. Anybody get anything else different? There we go. Okay, so if you didn't get this, let's everybody take another minute. If you didn't get it, put it in again. Okay? You need to type it exactly the way it looks. If it helps for the 1/4, put in a 0.25 instead. Okay, that might help some of the issues. You also need to make sure that you close this parentheses, right? I would make sure you have the control divide on. Don't try to do it with just a bunch of parentheses. It makes it too complicated and you'll miss something somewhere. And you might end up with a decimal point, right, if you use the 0.25. This is what I wrote down for last year. So both of these are correct answers. We looking better now? Yeah. Okay, because again, you got to be able to put it in. And you guys, with these, we're not going to be able to avoid the fractions. Okay, the fractions will be there on the test. You got to be able to put in the hard fraction on the calculator. Okay. All right. Now it's a decimal. So how should my answer look? Should look like a decimal, right? Okay. We got to be careful though. Look at this. It's not 0 anymore, is it? So I really need to be careful about my first term. Let's calculate a sub 1 real quick. If I put a 1 into that, I get 4 times 0.3 to the first. That didn't zero that out, did it? So I can't use my little shortcut on a sub 1. What does that equal? What's 4 times 0.3? 1.2 is my first term. I'm going to put that in before I forget it. All right, what's your n? What's our biggest number that we're supposed to go to? 12, right? It's hiding up in the top. All right. 1 minus... Does the ratio location change? No, it's still 0.3, and we're going to raise it to the 12th power there. Over 1 minus 0.3. Parentheses and control divide stuff, not as big of an issue, right, on this one? All right, so I'm going to give you a minute. Don't call out the answer yet. Give everybody a chance. I'll tell you when I want the answer. Okay, so everybody try it. And again, decimal answer this time. All right, what are we getting? Everybody okay with 1.714? Yeah. Awesome. All right, the next one's a weird problem, okay? And looking back at my notes, I've skipped it the past few years, but then after teaching the second year calculus class, I've realized that this is kind of an important thing for you at least to have seen before, okay? Most of it's not so bad, except for getting the end value, the figuring out what number that is. So let's try it. So summation notation is the funny E-looking thing, right? The sigma. All right, and I'm going to say, let's say it's n. You can pick whatever letter you really want, but I'm going to pick an n. And I'm going to start with 1, and I don't know what it's going to end with. Okay, but I'm going to start with term number 1. Okay. My first term is just, or what's my first term? 7. What's my ratio between the terms? 2. Yeah, it's 2, isn't it? And then don't I put it into the n minus 1 power? Because if I think about that, if I'm starting with 1, doesn't that get me 0 there? So that becomes the first term. So all I did here was I used the a sub n formula, right? To figure this part out. Question is, where do I end it? There's a couple of ways I could do that, okay? If I went and I used my a sub n formula, because I did calculate it with it this way this morning, okay? Which was a 7, our ratio was 2 to the n minus 1. In order to solve that, we need logs, which we could do. We've learned logs, okay? However, this is pretty small. Could I just figure it out? Couldn't we just count it out? Yeah, okay, so we've got 7, 14, 28. We are multiplying by 2, so what's 2 times 28? 56. Okay, we're going to need calculator help, right? What's 2 times 56? 112 times 56. 224 times 56. 448 times 56. So did we get where we needed to be? Yep, so we've got 1, 2, 3, 4, 5, 6, 7, 8 terms. Okay? Not so bad, right? You got to think of this and remember that all you're doing here, it's a fancy way of asking you to put it in the a sub n formula. Okay? And again, we could do it along with logs. If it got bigger than that or was going to go further than that, I probably would have just suffered through the logs. Okay? All right. Let's go for this one. Okay? Write that down. You need to make sure you write this and this piece of it. I don't know. Does the word where there? Okay, yeah. So make sure you write the absolute value of 1 or less than 1 after it. Okay, So again, I've told you, we're going to just take the word for it that we can actually find the sum of something that's infinite. Okay? It takes calculus to explain it. All right? So it is explainable, but you're not ready for the explanation yet. Okay? Give us about a year, right? So infinite, you will be. I guarantee you will be ready for the explanation someday. We're just not yet. Make sure you underline that word infinite because this is a different formula. Notice, is there any n? No, because we know it's going to go to infinity. All right? So, this is just going to stand for the sum again. This is the first term, right? And what's the R stand for? The ratio, right? Okay. All right. But there's this other thing here. There's a condition on this that you need to be very, very careful of. It says that the absolute value of R has to be less than 1. So basically your ratio, in order for this to work, only can be between -1 and 1. All right? So make sure that we have to check that ratio out first. And if it doesn't fall in there, I can't find the sum of an infinite geometric sequence. So it's only a small percentage can we actually find the sum of. All right, let's look at the first one. So, is this ratio between -1 and 1? Yes. Okay. So I'm going to say the sum equals, well, here's our formula, right? 1 minus R. So S equals, let's make sure our first term works out. Notice it only went to the n power. So if I put a 0 in there, what's my first term going to turn out to be? It's just going to be 4, right? Because anything to the 0 power is 1. 1 times 4 is 4. So my first term is definitely 4. But you always want to check that. Make sure that it works that way. Want to watch. Make sure if it's 0 on all of these, right? Okay. 1 minus R. What's your R value? 6.6. 0.6. All right. Punch the buttons on the calculator. What are we getting? 10? Okay. Would I get a different answer if I changed that to a 1? Yeah, that would change my first term, wouldn't it? Okay, so again, you got to be careful. You got to watch what that first term value is. All right. We okay on that one? Oh, yours is a 1? Oh, okay. Go ahead and change it to a 0 since we've already done the work. Okay? I wondered why I had the 1 there. Yeah, I'm apparently. I wrote the 1 in over the top. Okay, so fix it to a 0. All right, let's look at this one. Is this one a 0 on yours? No, it's a 1. It's a 1? Yeah. Okay, let's change. I'll switch mine to a 1 and we'll do 1 with the 1 in there so we've got practice on both. Okay? All right. So on this one here, let's find our a sub 1 first. So our a sub 1 is 5 times 1/2 to the first. So that's 5/2, isn't it? Well, and 5/2 in decimal is 2.5. All right, so my sum formula, I don't know why I wrote an equal sign. So I take the 2.5, okay, and I do 1 minus, what's the ratio? Oh, is my ratio between -1 and 1? Yeah, we always want to check that first. All right, so it looks like I've got 2.5 divided by 0.5. What does that end up being? 5? All right, let's look at 18. What's your number on 18? Is it a 1 or a 0? Okay, so first of all, is the ratio okay? It's between -1 and 1. All right, if I put a 0 in, what's my first term going to end up being? 6. Okay, I'm not going to give you, I'm going to stop. You guys figure it out. So take a minute and try it on your own. All right, what did we get on the numbers?
18.
8 came out to 18? Nice. Well, that actually wouldn't be too bad, right? 6 over 1/3. 6 times 3, right? All right. Let's keep going. Last one, right? Check your ratio. What's the ratio this time? Is that between -1 and 1?
No.
That's greater than 1. So can we find this one? Nope. So we would say not possible. Because notice, it says, if not possible, explain why. Okay? And I would say because, and I'm going to be lazy, B/C, because R is greater than 1. It's math class, so we don't need to spell out the word. I'm actually kind of disappointed. My daughter's teacher stopped doing spelling tests this semester, in January. In 3rd grade, no more spelling test. I know. Maybe it's to give them more time to memorize their multiplication tables. If it's for that, I guess I'm okay with that. Because she doesn't have those down yet. Alright, it's driving me nuts. Okay, let's go ahead and do homework, right? Oh, actually, I want to show you something. Let me stop the recorder. Okay, so everybody get on high